Hi, Ben with Novelux Stereophonic. In front of us here today, I have a Marantz 7 all-tube preamp from the 1960s. The backstory on this unit is I had a customer contact me. He had purchased this piece sight unseen, and after receiving it and opening it up, he realized that it had been heavily modified and not really in a good way. So he reached out to me, and after looking at some pictures of the unit on the inside, it looked like there was enough there to salvage it. So I decided to take on this project, and the scope is going to be basically tearing it down to the controls and rebuilding it from scratch as close as possible to the stock schematic. So if that sounds cool, stay tuned. I'd like to document the condition on arrival of this unit before we get started. If we look at the top cover on a stock Marantz 7, you've got ventilation here and here. So all of the holes in this area and this area have been added. So somebody went in and did their best to drill some holes that look like the original, but they didn't do a very good job. So this top cover is a little bit compromised. And along with it, these screws are incorrect. So on a Marantz 7, all of the outside screws are going to be these dark brown Phillips head screws. So anything else that we're seeing has been replaced at some point in the past. So we see a lot of vitamin Q capacitors. Somebody was trying to do an upgrade in here. This coax is not original. And actually this is like a 5-conductor cable with a shield. Completely unnecessary. It was just, somebody probably using what they had on hand. This terminal strip is not stock, so some circuitry has been added here. There should be some electrolytic capacitors in this area which are gone. My biggest challenge here is going to be on the back panel. So you can see it looks like maybe this was all set up and working at one point, and then either somebody was trying to take it back to stock, or it was just maybe parts were getting salvaged from it for some other reason. But it looks like it was originally all connected up here. Let's take a look at the back. So it looks like whoever modified this created some sort of acrylic or plexiglass plate here, and the same type of plate must have existed up here, and maybe it got pulled off. But in order to pull off putting these bigger jacks in, they had to pull the rivets on these original RCAs and then drill a bigger hole. So the back panel is ruined on this piece. What I'm planning to do is leave the low-level inputs alone and then build a single plate that covers all of this hackery and set it up nicely for whatever jacks are going to permanently stay in the unit. The original controls for the tape EQ are gone, so and when I get to that part, I'm just going to eliminate that from the schematic. That's one of those features that doesn't really get used very often. Let's take a look at this power supply. So the pictures that I saw of this unit, this cap wasn't broken. This probably broke in transit, so the phenolic base on this is snapped off. These capacitors are held in by zip ties, which required drilling extra holes in the chassis. So over here, some extra holes were put in. Normally there's only one hole over here for the high voltage rectifier. While we're in this area, check this out. So there's looks like an LM340. That's probably going to be a voltage regulator IC. Marantz enthusiasts looking for a vintage piece don't want to see any silicon besides rectifiers, diodes. Not going to want any transistors in these things for a purist. Looking more at the bottom of the power supply, a whole nother terminal strip has been added, and the really bottom of the barrel, they went with these nice vitamin Q capacitors, but then Chong X. I'm wondering if somebody had a stock power supply in this at one point and then did like a recap on it, and then somebody came in later and did a bunch of hack work. It's kind of hard to tell, but some of the work looks really clean, and there's other spots that are really botched. This whole area here is probably a redesigned phono stage. This is all going to get pulled out. We'll go back to the stock phono stage. Before I go any further on this project, I need to verify that the power transformer is good. So I've got 2 meters connected here. One is connected across the high voltage secondary, and the other one is connected on the filament secondary. So I'm just going to slowly raise, let's see, power on, slowly raise my input voltage here. Right now I'm at about 30 volts. So far, so good. I'm just going to crank this all the way up to 117. Almost there. All right, there's 117 volts coming in. And it looks like my filament supply and my high voltage supply are intact, so this transformer is good. I'm going to be doing a lot of work on this unit and manipulating the chassis quite a bit. So I'm going to pull off the knobs and the faceplate so that I don't cause any additional damage while I'm doing that. If we look here, there's a little bit of shipping damage on this corner. It can really only be seen in the correct light, but I'm going to try to bend that back. So it's just a really slight bend. I'm hoping I can bring this back in a vise and then it won't be noticeable. All right, so to take off the knobs on one of these, it's going to be hex. Let's see. I'm going to try 5/64 off the top of my head. Yeah, that's it. So this is an American design. It's SAE. These have a mix of a notched shaft and a solid shaft. In either case, the knobs, doesn't matter which goes on which one. That's not stock. This control's been replaced. If we look at the volume control here, you can see that somebody has, it can even feel that it's not straight. They didn't even take the time to file this. This got filed off, but when this got cut off, this wasn't done straight. And even looking at this, let's see. It sits too far off of the faceplate. So this volume control has definitely been replaced, and somebody didn't take the correct time to give it the right fit. So I'm going to be changing this to an Alps control anyways, and we'll get the depth correct on that when that happens. All right, let's continue taking this thing down. Just going to pull all these knobs. Interestingly, on this one, the power control is cream colored. I'm gonna have to look and see. This may have been swapped. It may be original. If it's original, I might recommend to the customer to go to a cream colored hat switch, because that ends up looking really nice if you do all cream on the front. I've seen some pictures like that and they look pretty fancy. So we'll see. I mean, the back plate's obviously going to be compromised, so it might be okay to do that. All right, next up, I like to use a rocket socket. I'm going to guess again here on 1/2 inch. Yeah, it's going to be fine. So this is a product that I really like. It allows me to easily take off faceplate nuts without risking a slip and scratch of the faceplate with an adjustable wrench or some other metal tool. Oh, that's really loose on the subplate. That might be missing a nut, which is not a good sign. I'm really hoping that the tone controls on this have not been touched. A lot of times when people do modifications on these, they either bypass the tone control or they just leave it alone, because when you have it in the flat position, it's not really in circuit. So hopefully I don't have to do anything to the tone controls, because those are big stacks of capacitors and it's kind of tight in there. It can be very time consuming. This one again is loose. So I think somebody just forgot to put all the nuts back on. We'll find out in a second. This nut looks rusty, where the other ones did not. So it's probably not a factory nut. All right, I'm gonna overhang this over the edge, and I should be able to just take this faceplate off. These should not be loosey-goosey in here. And you can even see there's like a ring around here. These all used to have a nut on them. And the faceplate would have, and that's probably why all the knobs look kind of spaced out. The faceplate will hover on here, you know, a nut's width off the front face. So yeah, something's not correct here, but we'll get it all sorted. The nuts that I pulled off the faceplate, I just put back in this location just so that these controls aren't flopping around in here. And now you can see the chassis sits flat. It's going to be much easier to tip around and get to these boards and stuff. So that's that. And then the faceplate itself, is actually in really, really good condition. Most of these little light blemishes are going to polish out. So I just have to take care of this little bend in this corner, polish this thing, and we should be in really good shape with this faceplate, and this piece will end up looking really nice from the front. Now, with a little bit of study of what's going on in here, I could figure out where to connect these leads and get this power supply back up and running and maybe do a baseline test. But I'm really not interested in doing that. The power transformer is good and the metal parts are pretty much intact. So I'm just going to rebuild this to the stock layout first, test my power supply. Once that's all sorted, I'm going to rebuild the main card here and do some basic testing of the line and phono stages, and then it'll be all about getting all the switches and peripheral stuff connected. So I'm going to go ahead and start chopping out this power supply. On the original design, there would have been a nice group of black wires running in a U shape from the power supply chassis to the main board. Very nice design. So all their voltages got arranged from here in a specific order so that they can come in nice and tidy to this board. Marantz 1960 stuff is very well designed layout wise, very logical. So somebody has gone and done away with all of that and wired the power supply directly into the first tube stage. So these wires mean nothing to me. I'm going to end up replacing this bridge rectifier with a modern bridge. But I may end up using this. This is for the filament supply. I'm just going to cut this out. I may end up reusing that board just because it will match the holes that were drilled in the back. All right, let's see what else can I snip in here. I don't want to do any of the original wiring related to the fuse, but whatever's going to this board is not needed. Okay, that seems to be free. This must be ground. Power supply or power transformer wires. It's going to be for the lamp. I don't think that's original, but I'm going to leave this as full length as possible just in case it is. Where is this brown and orange going? Oh, that goes up to that regulator IC. That's going to go. This looks like the original. That's probably the original lamp there. I don't know what this yellow one was. I'll find out later. But again, trying to keep these full length. I think that is an original wire. I think that's free. So it's just 2 screws on the side here. And I can't forget to clip these zip ties that are holding this power supply together. So this again, this is what one of those original chassis screws looks like. Normally this would just drop out of here, but it's going to be held on by these zip ties on the bottom. And this has all been drained, so I don't have any dangerous voltage here. There we go. These weren't even tied into these spacers. They were purely held in by zip ties. That's unacceptable. This is not an acceptable way to rebuild a power supply. The parts may have been okay, but yeah, this is the definition of hackery. And look at some of these solder connections. This big resistor here, it's not even wrapped around anything. It's just tagged right onto the side of a terminal post. So yeah, I'm not very impressed with that. Let's get this other board out. On the main board again, stock would have been black wires coming up really nicely. They've maintained some of that for these connections here, but the wire's been changed to some solid core copper. This is usually stranded so that as this sub chassis bounces, and we'll see, I don't know if the original suspension is intact. This is a suspended chassis, so it rides on little rubber spacers, and those stranded wires help with motion. This should probably not be solid core, but these 4 wires will go, and then there's going to be some coax in here somewhere. That's going to probably be accessed from the top side. So I'm going to undo from the back these 3 suspension points, and then we'll deal with the coax from the top. So this one, grab a nut driver. Oh, I'm on a roll. 5/16. Now all of these should be these little cap nuts. And this one's been changed to a Phillips head screw, so another incorrect part used. And who knows, it's possible that this was modified many times in the past, and I'm just the most recent technician to get my hands on it. This doesn't feel right here. I think this might, let's see what this looks like. This might just be a spacer that's going through instead of having the rubber suspension. Oh yeah, this was just nuts. So let me see here. I think I have, yes. I stocked up on these a while back because I work on quite a few Marantz 7s, so I have brand new shock mounts and can get this thing back up to its stock suspension level. This should come free. Okay, so that chassis is out, but it's going to be connected by some coax up here. Okay. I don't think I'm going to reuse this coax, but it's just about the right length. I'm going to be replacing this volume control 100%, so I'm going to clip it out here. I don't like the way that the shaft was on there. I'm going to use an Alps control. The original volume controls in the Marantz 7 are generally not very good. I've only seen maybe 2 that had decent enough channel tracking to stay in a unit. So I really don't mind replacing those at all. There's a piece of, looks like monster speaker wire connecting that phono stage. Oh, we've got this here. I'm getting close. What's this? So this is connecting into the selector. This is probably the output from the phono stage. The wiring that was used here is actually pretty nice and it's color coded, so I'm going to cut those really close to the socket because I might reuse these wires. Blue and orange, these were disconnected already by the time I got my hands in here. Let's see. All right. So now this project is in 2 parts. This will be one thing, getting rid of any modification that's been done in here and getting the wiring harness and everything set up. And then the other part of the rebuild will be focusing on this piece and this piece. Here's a closer look at the suspension system here. And this one looks like it's been replaced at some point in the past. It's actually in pretty good shape. This one here may be original and it's right about to just fall off and turn to dust. So that's what happens over the time. Sometimes if you'll get one of these that's been untouched over the years, these will have completely disintegrated and your preamplifier subchassis will just be floating around inside of the unit. Before the owner of this unit reached out to me, he happened to have purchased a couple parts kits on eBay to restore this unit. And luckily what we have here for demonstration purposes is an example of a bad kit and a good or acceptable kit. So I'll go into that next. Okay, so in this section, I'm just going to go over some of my own personal experience with eBay parts kits and just some general warnings to anyone that's looking to buy a parts kit like this on eBay. So first off, as a full-time technician, if a customer comes in to me with a restoration project and says, hey, I've got this parts kit, can you use these parts in the restoration? 9 times out of 10, I'm going to say, no, sorry, you should have contacted me first. I don't really install third-party parts kits. And here's the reason. I don't know the provenance of these parts. The person that built this kit could have sourced these from China or elsewhere, and they may be counterfeit. They may not be the correct value or correct voltage. So it takes me more time to vet the parts coming out of this bag than it would have for me to just have created the parts list and ordered it myself. So that's issue number one. Issue number two is a lot of these kits are built by somebody that's just looking at a schematic. So you end up with maybe a correct value part, but if you look at this one down here, look at how short these leads are. In a tube amplifier, a lot of this point-to-point stuff, it's better to have the tubular axial style pieces with long leads so you can actually reach to the points. On something like this, you'd probably have to end up hacking on additional leads so that you could get enough length to mount the part. In addition, on this specific kit, I can tell just looking at this bag that there's a lot of unnecessary parts in here. This would be asking the end user to replace probably every bumblebee on the tone circuit, and it's really not necessary. So those are, you know, just a couple of reasons why I don't install third-party parts kits for the most part. Now on this specific kit, this is what the seller has supplied to rebuild the power supply, and this is really a disservice to an end user. The way I think about this is somebody that's ordering a parts kit on eBay is probably somebody that doesn't have the experience yet to go out and look on Mauser or DigiKey and order all of the parts that are needed for the project. So already you're having somebody that's more of a hobbyist than a professional technician. And then you're going expecting that beginner hobbyist to open up metal multi-section electrolytic cans and correctly restuff them. That's not the way to do it. So my general rule, if somebody, say it's not somebody that wants to have me do a restoration, but they're going to do a restoration themselves, and they say, hey, is there a good parts kit available? This is my fifth tube preamp that I'm restoring, and I want to know what a good kit is. My general rule of thumb is if you're working on a tube device, if the kit does not include multi-section electrolytics, don't buy it. You should not be required to restuff capacitors as part of a kit. It's just a disservice to the customer. So off the bat, just take an initial look at the second kit. This was obviously designed by a technician that works on the Model 7 and not just looking at a schematic and speccing parts of the same value. So if we look at these axial electrolytic caps with the nice long leads, those are going to be placed around this area on the main preamp board, and they need to stretch quite a distance between the mounting points. The equivalent capacitor on the other kit would have been something like this, where the seller expects you to heat up the cut tape, pull the capacitor out, take one of the leads, bend it around, extend it, and then you can finally mount it in place. So you're going to end up with a hacked looking job instead of a more factory finished look. So that, you know, just little things like that. This bag has some terminal strips to make the mounting of the rectifiers more clean. So this seller's actually gone through the trouble of supplying everything you need for a clean, accurate rebuild of the unit. Here are the main multi-section electrolytics that were supplied in the kit, and those are going to mount into the original spacers. I'll have to repair this one, but you know, those will mount right into here and look much cleaner. Now, what I tell customers if they ask me about a kit, using a kit on their restoration, or say, hey, I'm bringing you a Marantz 7, do you want me to buy that eBay kit? I'm going to tell them no for the reasons I discussed earlier, and also that I can end up with a better execution if I specify the parts myself. So I use a company called Hayseed Hamfest and build a lot of these custom capacitors for my projects, and I can get the exact value. So on this capacitor, for example, these two are really exactly what we need, except one extra section in this cap, which is not a big deal. This one is supposed to technically be 20 microfarad, and it's 50. So the value is slightly incorrect on this if you're going to follow the stock schematic exactly, but in circuit that's going to be just fine. But when I do one of these kits, I basically make a reproduction of the original capacitor for height, diameter, the location of each section on the actual multi-section filter cap, so that I can copy not only the stock schematic wiring, but the actual layout of the wiring on the capacitors. So for about the same price, I can give the customer a little bit better of an execution. So I hope that helps with parts kits. If you're interested in restoring a Marantz 7 yourself and you have the experience, a parts kit like this is going to be a pretty good option for you. I would avoid stuff like this at all costs. So that's my warning and my recommendations on eBay parts kits. The next thing on the list is gutting these boards so that we can rebuild them from the ground up. The next thing that I'm going to tackle is starting the rebuild on this preamp board. So I'm going to start by cleaning all the flux and the dirt and stuff off of these boards. I'm going to move on to rewiring the 12AX7 jacks, the filament leads here. I've got some nice Teflon coated silver plated wire that I'm going to be using for all of my replacement wire. And then I'm going to start on the back side with repopulating all of the resistors. So I have a pretty sizable stash of Allen Bradley carbon composition resistors, 0.5 watt, 1 watt, and 2 watt. So I've gone through and selected all of the resistors that I need to get this back to a stock layout. And I've got a pretty big supply of these, so I was able to get values that are extremely close in tolerance to the original value on the schematic and match the resistors to one another. So all these 1 meg resistors, for example, are matched very close to one another. So I probably had about 50 of these and was able to select a handful that measured very close to one another, and that goes for all these here. So I'm going to get this cleaned up, rewire the filament wiring, and then start populating the back side of the board. This is just 99% alcohol going on here. I'm just trying to loosen up any of the flux and dirt on here. So that's one side done. I'll go ahead and duplicate this procedure on the other side, and then we'll clean up the tube sockets. Okay, the other side is all cleaned up. I'm now going to remove these old deteriorating shock mounts and then thoroughly clean the metal here. So that ended up looking a lot nicer than previously, and I'll be cleaning some more here as I work on these sockets. So normally I would just gut something like this, but this is a weird wiring scheme because it runs on 18.9 volts with 3 filaments in series. So I'm going to just work one wire at a time as I go and get these replaced one by one. I just finished rewiring the 18 volt supply. I had to dig into some old pictures to figure out how these wires got connected down here to where this crosses over to the power supply. Whoever was in here before built their own 18 volt supply and was running the wires straight in. So in the end, it looks like this is all ready to go. The concept is pretty simple. So basically the brown wire comes into the center tap for the filaments, and that forces the voltage to go through one of each of these filaments in the first tube, and then these brown wires carry it to the next tube where it goes through the entire 12 volt filament and then back to ground. So if we count the filaments when it comes into this tube, we've got 1, 2, 3, and then from this one, 1, 2, 3. So that's how we get the filaments powered on 18 volts, and then the same thing is duplicated on this side over here. So all that wiring is now done and ready, and we can move on to mounting the resistors. I got a little bit ahead of myself here. I need to do some more prep work before I can start with the resistors. I have 3 more power supply voltages that I need to tie in here, and then I also need to run a ground bus across here. So I'll get that done, and I'll come back in the next shot. All right, all the wiring for this side is now complete. I ended up using just some Romex here for the ground bus. And I came around getting this all nice and clean and wrapping this around here, and then I forgot there's a little extension here that comes past to mount some components. So I just tacked something on there. Once I get resistors supporting this, I'll be able to clean up this joint. But overall, good to go and ready for resistors. I just finished placing all of the carbon composition resistors on the main preamp board here. I did run into a couple of snags on this, especially in this area here. I had to take a long time to study a bunch of schematics, and I ended up deferring to the VAC reissue because I'm assuming they're on the latest version basically. So I've seen a bunch of different things here. Some of them, instead of a 1 meg resistor here, there's a peg here and just another one of these little jumpers to bring the ground bus to the other side. Some of them have a 1 watt 1 meg. Some of them don't have anything at all. So I think it's something to do with floating this ground bus for the second phono stage channel. But again, I just deferred to what I saw on some high resolution pictures of the VAC reissue. So this is another area here which is kind of neat. They bring the tube shielding and this whole sub-chassis section to ground via this little jumper here. Another snag I had was these resistors here. So this is supposed to be a peg that looks like one of these, and both of them were snapped off on this side. So I needed to do a test here. I put some flux on a big solder ball and soldered one of these resistor leads in, and they're in there pretty solid. So I was thinking about running them from the other side, but I wanted to keep a stock look, and I do have some other resistors that are going to be going in here. So that's kind of where I got hung up. Luckily, I have a ton of pictures of these. This is probably my 7th Marantz 7, so I have a lot of very detailed close-up internal pictures, so I was able to get a really nice result here. The rest of this is going to go fairly quickly. I just have to put the deposited carbon resistors in on both sides of the board, and then most of this is going to be the coupling cap. So this should go pretty quick. We're almost done with this preamp subchassis. Here is the completed main preamp board. Where I left off last time on this one, I had just finished all of the carbon composition resistors. Since then, I've replaced all of the deposited carbon resistors with either their current name, which is carbon film, or in this case I had to go with metal film because they didn't have that exact value in carbon film at the parts house that I was ordering from. I've got the coupling capacitors installed down here on the tube sockets. I had some issues on this side. This coax was completely missing, so I needed to recreate that. I had another snapped off lug that I needed to deal with, and then one lug that was completely missing. So what I did is I just used one of these extra holes that was drilled in here to mount a single terminal strip to mount this capacitor. I did want to touch on some parts kits notes. So the parts kit that we're using on this has been really actually very good, but there were just a couple minor issues with it. So you can see some of these capacitors are installed opposite one another. Same thing on this one here. The reason is I marked the outside foil on each of these to minimize the noise floor. And when I'm dealing with a parts kit, they only give you the exact parts that you need to complete the unit. If I'd been specifying this myself, I would have had, you know, a stock of 10 of this value, for example. And after I marked them all for outside foil, I would have selected the ones that have the outside foil on the same side of the writing, just so everything lines up. That's just me being nitpicky on that aspect. Another thing that came up was this capacitor value on the schematic is 200 microfarad, but in the parts list and in most of the example units that I've worked on, it's 250 microfarad. So I was supplied a 200 microfarad with the kit. I needed to swap that out to maintain the value that I normally use there. So that's it for the preamp board. Moving on. While I'm waiting for some parts to come in, I'm going to get started on rebuilding the power supply. So the first step is going to be mounting these multi-section cans into this little chassis, and then hopefully it will sit flat and I can rebuild it in this orientation. So I've encountered my first hiccup with this kit. This capacitor doesn't fit in this location here. It was supplied with these things. I think there's some instructions about drilling this out and just putting these pads in here or something, so I'm going to check on that, but I don't really like that. I have the original spacer in here. I think I'd like to maintain that, so let me see what else I can come up with. This is what I came up with. I looked through my stash and I actually have a extra hayseed capacitor from a previous order that's pretty much what we need. So it has this pattern that's going to fit perfectly inside of this clip. And this one is rated at 50, 50, 50 at 450 volts. I only need 350 volts, but this is going to work just fine in this position. The stock schematic on here is 20 microfarad for each of these sections. When I do my own custom order for these, I end up doing exactly what the original values were with a little bit of extra voltage tolerance, but this should work fine with 50 microfarad. That's what was supplied in the kit. So basically I'm taking the cap that was supplied here, upping the voltage a little bit, and just changing the form factor so that it's a little bit easier to work with. So now I'm gonna, I think maybe if I put a hockey puck or something in here, I'll have to find something to shim this so this sits flat for me. Once I can get it to sit like that, it should be pretty easy to wire this thing up. Here is the fully rebuilt power supply chassis. I ended up doing all new wiring on this because the original was all messed up. Normally I can salvage the original wires here, but in this case I just went with all new. I also did all the resistors here. I've just kind of strategically spaced them so that they each have some room to breathe. And by default, this pin here and this one here are empty. So I strategically use those to add a rectifier here. This is just a high current diode, and it gives me a 500 millivolt extra drop on the filament supply, which brings the voltage closer to 18.9 when we're switching from selenium to silicon. So that's all been done. This thing is ready to install back in the chassis and get tested. Rebuilding the preamp board and power supply assembly on the Marantz 7 is a pretty involved process by itself, but actually what I've been dreading the most in this project is dealing with this absolutely hacked rear panel. So I was speaking with the owner about some various options, maybe doing a metal plate that covers all of the jacks and remounting everything that's needed, and maybe just keep the key features that he wanted to use, or mounting some jacks in these holes that have been drilled, but it just was never going to look really good, and this is going to end up being a pretty nice piece when it's done. So as we were discussing that, he ended up finding this on eBay, and when we saw it, we snatched it up immediately. What this is the rear panel of a Marantz 7K. So if you see this as 100 volt here, this must have been a Japanese market only release, but at some point in the past, Marantz released the Marantz 7, 8B, and 9 in kit form for people to assemble themselves. So we have a pretty much identical copy of Marantz 7 back panel with rivet mounted RCA jacks ready to go. So this is going to save a bunch of time and fabrication and end up with a much cleaner look. The only downside is I'm not going to be able to reuse the original AC outlets because these are a little bit smaller than this cutout and are riveted in, where this one uses like a push-in type AC socket. So I'm going to end up removing this back panel and we'll repopulate everything onto this guy. I had high hopes that this selector control would have been mostly stock wired, but it's got some missing resistors and a lot of other stuff going on. So I think it's gonna be better if I just pull this and gut all the wiring, replace any missing parts that need to go on this, and then start to tackle whatever hackery took place in this. I'm hoping that nothing was touched here. So I've done just about all the studying that I can on what was here to give me as much information as possible. So I've got that clipped out, and now I've got the chassis separated, and this is an L shape like we saw before. So now I can fully separate off this back panel. It looks like all that's holding me in now is the power wiring. Now that I have the front panel separated, I can get a closer look at the hackery that was done to this thing. All the orange wires in here is something that were added. I don't think any of these orange drop capacitors are original. Hopefully it was just somebody trying to do an upgrade and not a lot of the wiring's changed. This is going to be a bear to figure out. Lots of, I think all the yellow wires in here is something that was added. I got some clipped wires and tacked on stuff here on this mode control. Volume control is not original, as I mentioned before. So a lot of work ahead of me on this panel to try to figure out this wiring. So after doing some more circuit study and looking at a bunch of pictures, I think the majority of this tone control wiring is correct, but it's been redone at some point in the past. So if we look at some of these solder joints, I almost guarantee what I'm going to find here is when I desolder these existing wires, I'm going to find remnants of another wire behind there. I think what happened is at some point in the past, somebody probably took this down to kind of a bare bones 2-channel preamp with volume control and clipped out a lot of the erroneous circuitry that they didn't want in there. And then at a different time, somebody went back and tried to return it to stock. So I get kind of, you know, almost the stock schematic, but with really poor wiring. So I'm going to go in and just start cleaning this up little by little, one switch at a time, and hopefully I can get this front panel all back to stock before we put things back together. The two resistors that I'm going to be replacing here are 6.8K and 8.2K. And I'm just replacing them because I'm cleaning up all of the connections here, and it's easier just to pull them out and redo them than to try to reuse these resistors that are in there. I was going to use these carbon composition ones, but all I have is 4 of each in my stash, and it's not a big enough sampling to get identical parts. Like some of these are slightly different package, and they've all drifted a little bit. So I'm just going to end up using metal film in this circuit. This is just the high frequency filter, so it's not going to be a big deal sonically. Okay, I've made some good progress here. I've rewired the entire first section of this switch, came out nicely, and the biggest gain was getting the color code on this harness corrected. So I'll be moving on to the other switches, and hopefully the rest of this goes smoothly. I'm getting ready to rework the next two controls. So we have the low frequency filter and the Phono EQ. There's something wrong with the wiring on this control. This resistor is not correct, and these two capacitors here are the incorrect value. This is one channel and this is the other channel up here, and they're supposed to be identical and they're not. So what this would have done is when the low frequency filter was activated, the left and right channel wouldn't have the same frequency response. So I'm going to get that corrected and then redo this control while I'm in there. Here's another example of why I'm going through and rebuilding this whole thing. This is another wiring mistake. This is in the phono equalization. So this would have resulted in, again, improper frequency response between channels. You see this one has a yellow band and this one has an orange band. This is supposed to be 560K. So we have approximately the correct value there. But on the second one, incorrect value. So another wiring mistake here. I'll get that corrected. I've almost completely finished rebuilding the front panel here. Came out really nice. Now, if you're following along and you're thinking, hey, maybe I should clean up this section in my Marantz 7. If it's original, do not touch that. It's really not necessary. The only reason that I went in here at all is because of the wiring mistakes that I found, and just the general quality of the work was poor. So I kind of needed to go through everything just to correct the color codes and make sure that the circuits were all wired up properly. So again, if you have an original Marantz 7, there's really no need to touch this section here. This is the treble and bass tone controls, low filter, high filter, RIAA equalization. It's stuff that in most scenarios you're going to be running flat, and even if there is an issue, you're just going to get a very slight frequency response difference between channels as long as the components haven't drifted too badly. So if it's all original, I usually just thoroughly clean the controls and that stuff stays alone. So remaining stuff to do here, the volume control, I have to temporarily install and mark the depth on it so that I can cut the shaft to the proper length. And then the input selector I need to wire up out of circuit. It has a huge harness with some connections coming up here into here, and it's just a lot of work. So I'm going to do that out of chassis and load that in. I am still missing a couple connections here for my tape input, so I'll be running some coax from there. But at this point, I think I'm going to tackle that volume control and then move on to repopulating the Marantz 7K rear panel and getting these two chassis pieces linked together. For the volume control, I'm going to be using an Alps RK27 series 250K potentiometer. A lot of people get kind of uppity about replacing volume controls in Marantz 7s. They say the original carbon control contributes to the sound of the piece. In my experience on the 5 or 6 Marantz 7s that I've worked on, the channel tracking on those original controls is atrocious, and it's really unacceptable in my opinion. What it translates to is when you're raising the control, the amplitude does not remain the same throughout the range, channel to channel. So you'd have to constantly be on the balance control depending on what level you're listening at to get a balanced audio signal. So in this case, I really have nothing to lose. This is not an original Marantz 7 control. This is something with an unused loudness tap that somebody hacked in there. So I've got no problem pulling that out and replacing it. With this control, I'm going to end up mounting it in the chassis upside down so that I can clearly see all of the connections, and my connections from the balance control are going to end up looping up kind of like that. It should turn out nice and clean. So the first thing that I need to do is get rid of this little nub here so that it will sit flat against the chassis. Then I'm going to screw it in and use a caliper to accurately mark where I need to trim this so that the knob sits at the correct depth from the faceplate. The push-in AC outlets arrived. They're nothing special, but I already fit one in and it snapped right in place. So let's do the rest of these. Now I'm going to see how this goes on this side. On the original, I think they're very similar in how they were mounted. And it looks like they were just twisted to about 45 degrees to let a piece of wire come through the hole. So I'm going to try twisting one of those. If it doesn't feel very good, I'm just going to wire it up how it sits. That felt fine, so I'm going to go ahead and put a 45 on each of these. So it turns out that the original Heiko connector is too big to fit inside of this cutout, so I'm going to go with a smaller connector and a thinner power cord. I'm getting ready to install this replacement volume control. There's a little bit of play here because the diameter is slightly different than the original. Now, if I had thought of this before, I would have done this in advance. This is a shoulder washer from an RCA jack, and it works perfectly to center this control. The problem is if I put it on this side with the cut that I made on the shaft, once I add this nut, it gaps it too much and the faceplate won't sit on even. And if I put it on the back side and feed it through this way, then my shaft isn't going to be long enough for the control. I think what I'm going to do is dry fit the faceplate and see how it turns out. If this shaft is just a hair too short, it should still be okay because there's a set screw. So I'm going to mount that up, see how the faceplate sits, and see if that's going to work out. So let's take a look at the difference in depth on these shafts. So the original balance control is at about 17 millimeters. And with that shoulder washer offsetting this a little bit, I'm at 16.1, so I'm off by 0.9 millimeters. I think that's going to be fine. Let me fit up the faceplate and see how the knob goes on. So what I want here is a gap here, and I put it on once, you can kind of see the mark there. It looks like this is going to work out just fine. It is shallow enough that it'll allow the knob to hit the face, which we don't want, so I just have to gap it a little bit. Tighten it onto the shaft. There's a little bit of scraping there. Give it a little bit more. And there we go. So that's clearing fine. No scraping on the faceplate, and it's plenty solid, so that's going to be fine. Now, if I did this again, what I would do is I would put that shoulder washer on the back side and cut it to length with that in place so that it ends up the same length as all the other shafts. So I just finished what was the most complicated part of this entire project, and that was rewiring this input selector switch. So this thing had been pretty badly botched. There was only probably 4 or 5 connections that were actually still correct. A lot of things had been modified to facilitate whatever was changed in the preamp. So I've gone through and I thoroughly cleaned the control. And then after hours of circuit study and studying pictures, I was able to reconstruct this thing. So I'm about 95% sure I have all of this correct. At this point, I'm just going to wire it in and if anything is not working correctly, I'll have to dive back in and troubleshoot it. But this is done. Next step is getting this switch loaded into the chassis and making all the connections. I've got the input selector mounted here into the chassis, but before I move forward, I have to figure out what I'm going to do with the rear panel here. So I have the meter attached to ground here, so that's the actual ground lug on the back of the back panel. But if I go to the ground leads on each one of the jacks, I get a different ohm reading, somewhere between 1 and 30 ohms. So these should all be at chassis potential. I think what happens is resistance develops somehow on the rivet connection there. So in the past, I've had to go back and add little ground jumpers to each of these to bring them to chassis ground. But on this one, I'm not sure it's going to affect it or not. This is that brand new Marantz 7K panel. So I'm going to wire it up like normal with just the signal connectors coming into the center conductor. And if I get ground loops or hum or buzz or anything like that, I'll know where to look. The other thing that I need to address back here is the trimmer controls for the tape head EQ. This is just for if you're running like a reel-to-reel deck and running a signal straight from the tape head without going through the built-in EQ in the tape deck itself. It's not a feature that's going to get used every day, so I'm not too concerned about it. The original control is 15K. This one's going to be 10K, which means that the adjustment on here might not be on the line that's indicated on the back of the unit, but at least there will be some adjustment there. I'm more interested in getting a control that fits in there, looks good in the chassis so that hole is filled, and then I've got a place to land these wires. I'm about halfway done wiring this control into the chassis, so all of the front portion is done. I've wired up the whole bottom channel here. I've got the load resistors in for the phono stage. On the stock wiring on this harness would have been against the back panel, but since I've changed these potentiometers, I had to gap it out a little bit, but should be the same result. So let me go ahead and finish this up, and then we'll move on to mounting the power supply and the suspended preamp board. I completed wiring up the rear panel input connections, and then I went ahead and mounted the power supply module in the chassis. I needed to widen out these two holes. They were too small in that replacement backplate. So power supply is mounted, all the wiring is done. The filament supply is down here. There's a ultra-fast rectifier for the B+ supply on the top, which we'll see in a bit. I mounted an inrush current limiter on the power transformer primary. I missed that on the initial power switch wiring. And I've just got everything wired up here. We're going to do an initial voltage check before I mount the preamp module. So on the left meter, we have our B+, and the right meter is our filament supply. This is all going to be elevated because this is unloaded. I'm just looking to see that my voltages are there and they're relatively correct. So I'm at about 60 volts here, and I have B+ and filament voltage. So I'm going to go ahead and mount the preamp chassis in, complete that wiring, and then redo this check and see how our voltages end up before we do any audio testing. Next up, I'm going to install the shock mounts on the preamp chassis. I'm missing the cap nut for this one, so I'm just going to put a regular 832 nut on this for the time being, and I will try to locate a replacement down the line. All right, let's get this wired in. The output controls here I have are not original. This is what whoever was working on it before had put in. They're nice quality pots and the correct value, but they're a little bit bigger than the originals, and I can't have the terminals on this side because it'll end up making it very hard to wire these jacks. So I've got these mounted with the terminals on the right side. I should have plenty of length here to get that done. We're in the home stretch here. I just have to do this back harness and some coax, and then we'll be ready to test this thing. The Marantz 7 is officially complete. I didn't cover a lot of the final wiring on camera because it was so tedious, but everything is done and in place. I'm happy with how everything turned out. I'm just hoping that I didn't make any mistakes. This is a very complicated unit, and I couldn't really stop in between to test because those two boards were out, and I was starting with such a hack job. So we're gonna go ahead and fire this up. I'm assuming there's going to be a couple things wrong with it. It's just way too complicated for me to have gotten everything perfect on the first shot. So we're going to test this out and see how I did. Before I start the testing, I need to load the tubes back in, and I just wanted to cover some tube replacement strategy quickly. So if we look at the inside of the Marantz 7, you can see that the V1 and the V2 sockets have identical components. Same thing with 4 and 5, but V3 and V6 are shared between the left and right channel. Whenever you have a dual triode that has a left and right channel in one of each of its triodes, it's more critical that it's a balanced tube. So I'm going to pick the best balanced tubes to go in V3 and V6, and then try to get a couple pairs matched up for the other ones. So looking at my Amplitrex test results here, I tested these on an Amplitrex AT1000. This tube is pretty well balanced. I'm looking for less than 10%. This one's pretty good, 9% for emission and a perfect match for mutual conductance. That's probably my best match. This one is pretty close. Perfect for emission and off by 7% for GM. 8 and 6. Yeah, I think these are going to be my most balanced tubes, so that's going to be my 3 and 6. And then for these other ones, I'm going to do it like this. So that's going to be my tube complement. These are all 12AX7s. I'm going to load these in, and then we'll start the testing. Okay, this check is going to be same as before, except I've now got all of the tubes loaded and all the connections in place. So I'm monitoring the filament supply on the meter on the right and the B+ on the meter on the left. So I'm going to slowly ramp up the variac. $20 volts. This is good. When we did the test without the tubes installed, this was going up very fast. We want the filaments to land at 18.6 volts. I've got this on dim bulb. I'm not seeing any excessive current draw, so far so good. At about 70 volts coming in, it looks like the capacitors are charging for the filament supply. Let's keep ramping this up. I'm going to stop around 110. We'll see where we're at. So we're getting close to correct filament voltage. Let's take it up to 117. That's fine there. So we're on dim bulb. We're a little bit under on the filament voltage here, and also on the B+. I'm going to just hop this down to the other B+ voltages and make sure they just go below 260. So 240, it should be like 220 or something. Okay, so everything is relatively correct. We're a little bit low on filament voltage, but this should technically run. So next I'm just going to try to feed a signal through this thing before putting it on full power with no dim bulb. For this first audio check, I'm not caring about the input selector. I'm just running a signal into the tape input. So I've got the selector control down in the tape position, and I'm just going to see if I can pass a signal through the line stage and if my volume balance, tone, and filters work. So that's test number 1. Let's turn it on here. Wait for it to warm up. Ugh. Something's not good already. I've got some sort of power supply hum, and it's actually pretty loud. So I am able to get a signal through. This is me messing with the volume control here, so definitely something not correct, but as I said, there's a lot going on here. For me to have gotten everything exactly perfect was pretty low probability. All right, now I'll have to dig in and see what I can find. Unfortunately, I had some microphone issues while I was doing the troubleshooting on this unit, so I didn't capture the audio there, so I'm going to review it here now. So when I turned the unit on, there was buzz immediately as soon as the power switch was flipped. Normally, if I've got an issue with a B plus supply, a buzz doesn't come in until the tubes have warmed up. So this had me thinking filament supply. So what I did is I lifted the orange wire from the filament supply bridge rectifier and I substituted in 18.9 volts from my bench supply. And with that going, I was able to resolve the buzz. So what ended up happening there was I had the ground incorrect. So the black wire that goes back to my bridge rectifier here, I had plugged into this wire, which goes to the elevated ground bus or signal ground. So for some reason that was causing all kinds of issues. So when I moved it over to the correct point here at chassis ground, that resolved the buzz. So once I had that up and running, I located another issue, and that was phono stage was working fine, but in the line stage, one channel had excessive gain. It was like something like 5 or 6 times the gain of the other channel, and it had poor frequency response and incorrect response when turning the tone controls. So when I turn the treble control, it would partially work in the upper range, but in the lower range it would just go crazy. And then kind of the opposite of that on the low frequency, where I would get it in half of the range and then just no effect in the other half of the range. And what that ended up being was a cracked solder joint here at a very important 82K resistor. So while I was changing out these yellow wires, the lead from that original resistor must have cracked or something, so it was kind of sitting loose. So once I got that resoldered in, everything kind of went back to normal. So those were the 2 issues that I had with this unit, and now everything is working properly, and I'm going to move on to doing some voltage checks now that everything is sorted. I'm showing my filament supply here on the right and the B plus here on the left. The unit's been warming up for about 5 minutes and I'm plugged directly into an outlet. My mains right now is right around 120, so showing real world conditions here. Now the filament supply is supposed to be 18.9 volts. It's slightly low. Part of the reason for that is I've added this extra diode here, and this supplies a 500 millivolt drop to the supply coming into the board. So if I bypass that, you'll see my voltage jumps up a little bit. Normally I have to add 1 or 2 of these diodes to compensate, but in this one I don't. And my hunch is that Marantz had 2 versions of the power transformer for the Marantz 7. I'm not 100% sure on this, so if somebody knows that for a fact, please share it in the comments. But what I've noticed is usually I have to add compensation. So what I'm thinking from the ones that I have seen is that when it uses a selenium bridge, the difference, it might have more power supply windings on that secondary, and for a silicon bridge they may have dropped down the windings a little bit. I'm going to leave mine here with this diode in place. So I'm running at 18.1 volts, just a little bit over 6 volts per filament. That's going to preserve the tube life a little bit, so I'm okay with that. If somebody wants to in the future, they can just jump that out. For the B plus supply, I'm looking for 280, 265, and 245 from the supply. So right now I'm right around 280. Drop down to this one, it's supposed to be 265, right there, and 245. So my B plus is dead on. Sometimes if the original paper capacitors are still in here, the voltages won't match up because of the leakage. So with this one fully rebuilt, everything is looking perfect and we can move on. I got the Marantz 7 hooked back up to my patch panel and was getting ready to show off how well this thing was performing after the rebuild, and then I noticed one more issue. So what I'm showing here on the scopes, on the right side here I have the test signal that I'm feeding into the phono stage. This is a 1 kilohertz square wave that's being fed into an inverse RIAA filter. So this is basically simulating what would happen if I played a 1 kilohertz square wave directly off of a vinyl record and then fed it into the phono input. What I'm supposed to be getting on the output is a clean square wave, but what we're seeing here is a high frequency bump and a little bit of a tilt, so the frequency response is not correct. If we listen to this, it would sound a little bit tinny or a little bit too bright. So what I ended up doing was looking over all the wiring that I did. Everything was correct, so then I had to start looking at individual components. So this is a simplified diagram of the Marantz 7 phono stage that I located. Somebody online made this up. And these components down here in this area are what make up the equalization for the phono stage. So I went in and looked at those and I found some components that had drifted quite badly. So I didn't identify this right away because the response in both channels was identical. So whatever drift happened must have happened equally in both channels due to the environment that this was in. So the first component is a 1600 picofarad capacitor that is down here by the RIAA switch, equalization switch. What was installed there when I started was 1500 picofarad. It's supposed to be 1600. So I don't know if that was the person in here modifying and just put in something that was close, but it does affect it. It changed the high frequency response quite significantly. So what I did is I put a 1600 picofarad cap together out of 2 precision mica caps, and that really helped with the high frequency response, but the tilt was still messed up for bass. So then I went and inspected the components here. We have a 5600 picofarad capacitor and 680K resistor. So I've subbed in some precision parts here, and this is our result on the yellow trace up here on the scope. So the unmodified channel is red, and the one that I put the precision parts in is yellow. So you can see how the response has improved. I'm feeding in this signal and getting out a very nice looking square wave. So I'm going to go ahead and modify the other channel so that both are the same, and then I'll retest. I just finished putting all the precision components in, and our frequency response is much improved. The red trace does have just a hair of a high frequency rise there, but it's negligible. If we look at this a different way, feeding in a 1 kilohertz sine wave, as I raise the frequency here, we're going to see the amplitude of the right scope change. So the input signal is changing, but the output signal is remaining constant in amplitude for the most part. So that's 20 kilohertz, and we barely had any change on the left scope. So frequency response is good. If I go back to a square and we look at the RIAA switch on the front, this is me changing to the Columbia and 78 curves that are part of the Marantz 7 circuit. And remember, I had to change some components here. There was a resistor value that was different from left to right channel and some incorrect capacitors. So if I had left those capacitors in place, what we would have seen is the yellow and the red trace would not look the same as I do this switch. So everything's been corrected here. Phono stage is solid. I'm going to move forward with cleaning the face and the knobs and getting that put back on before we test the line stage, because it's much easier to manipulate the tone controls once the knobs are on. So let's move on with the faceplate and go from there. I'm going to be starting out with just soapy water for this first cleaning. So already that's looking much better. I have some stubborn marks here. Do one more round with the brush, and if that doesn't come loose, we'll go to polish. Oh, this is going to look really nice. I'm just going to do, you can see there's just some inconsistencies in kind of the reflection of this. I'm going to just do a very light polish on it, kind of to even out the look. I'm going to be trying semi-chrome for this. Whenever I'm testing a polish on a faceplate, some units I work on all the time, and I just know which compounds to use. On something that I'm a little bit more unfamiliar with or don't work on all the time, I like to do a quick check. So the least affected thing is going to be one of these dots. And this silk screen seems to be holding up fine. So I'm going to go ahead and just do a light polish on the whole faceplate here. Looking much better than when we started. There are some imperfections, a little bit of scratching in the upper left-hand corner here. We have that slight deformation here, which actually is not super noticeable, which is good. So we'll get this loaded back on and then move on to the knobs. Something interesting I found here on the small knobs. One of them is not like the others. Oh, actually 2 of them. So these were probably taken off of like a Marantz 7T or something. This is an original one, much more metal content. These are kind of thinned out, and the diameter is just slightly different. But what I'll do is end up putting these 2 on the bass and these 2 on the treble, I guess. When I'm putting on the balance control, I like to use the oscilloscope to set the control to the exact center and then install it with the line straight up, and then usually that lines up pretty well between. It's kind of hard to eyeball this one. There's no detent or no flat edge or anything. Getting down to the final touches here. Install a new lamp. So this is just on a little bar here. This is a number 49 lamp. A weird one, runs at like 2.5 volts. So let's see how this looks. Green. So it looks like what happened is whoever had been working on this before removed the original diffusion that was there and added a green jewel similar to what you'd see in like a Fisher or a Scott integrated amplifier from the 1960s. I don't have the correct part to put this back to stock, so I spoke with the owner. He's okay with the green, so we're going to stick with that. It does look pretty nice. It's just not stock, but the rest of this Marantz 7 is not stock either. We've replaced the volume control, replaced all the wiring, and almost all of the components, so I think it's okay that we have a slightly different color on the lamp. Now that the knobs have been reinstalled, I can better demonstrate the frequency response of the tone control and the filters. So what I have going on here is a 1 kilohertz square fed from the signal generator into the auxiliary input, going through the volume control and the entire preamp, and then we're looking at the output up here on this scope, and I also have the output plugged into this distortion analyzer for a dB reference for later. So let's start out with the response for the tone controls. So when we manipulate the treble controls, it affects the square wave on the front side. As I continue up to the top, you'll see that there's a little bit of a channel deviation, and this comes from drifted components in the tone controls themselves. Those are some of the only components in this piece that I did not change. And the reason being, most of the time you're going to be running this flat, and the tone controls are basically out of circuit. If we look at the tracking all the way up, they're pretty darn close up to this point, and it's just like those last 3 clicks, they're a little bit off. And if you are cranking the treble this much, you've got bigger issues in your system than a slight discrepancy in frequency response. If we go down the other direction, you can see that it tracks pretty darn well. The bass controls are also very even. This is again with all original components. So that's the bass controls. Let's look at the filters. So this is high filter. See how that changes the shape. Now, the original components that were in here, remember I identified those as incorrect. If I did not change those, what would have happened is when we activated these filters, the red and the yellow trace would deviate quite a bit. So I'm glad I swapped out those parts. If we look closely at this, you can see there's just a little bit of a tilt on this square wave on the bottom side, which indicates a slight frequency response deviation. This is the kind of representation of the tone controls from the service manual, and you'll see if we look at the line where the tone control is bypassed, there's a little bit of a dip down here at 20 cycles or 20 hertz. So I just wanted to demonstrate that here and also show the upper range of this preamp, which is quite impressive. So right now I've got a 1 kilohertz square wave. I've got, I don't think you'll be able to see it from this far back, but my lines on the scope here are lined up at the top and bottom of that waveform, and I'm at 0 dB here. I'm going to ramp this up first. We'll take it to 20 kilohertz. So this is 20 kilohertz at the top of the unit. We're at negative 0.1 dB, so very little deviation, but this thing basically goes into the stratosphere. So as I continue raising this up, we'll go to the negative 1 dB point. Negative 1 dB down's at 56 kilohertz. I don't get to negative 3 dB until close to 100 kilohertz. That's negative 3 dB right there. So you can see not very much deviation and only negative 3 dB down at 100 kilohertz. So if you're looking for a preamp that extends past the human range of hearing, the Marantz 7 can certainly do it. Let's go down the other way. So I'm going to ramp it down to about 100 hertz. We'll see where we're at there. Negative 0.57 dB. And then if I keep going down in... Oh, that was a mistake. That didn't catch up. So we barely have any deviation right now. I'm going to switch the range of the scope here. We're now at 40 hertz. Still very little deviation. And 20 hertz here. We're down at about negative 1 dB, which corresponds with that little curve there. So it looks like they captured the information correctly, and my work should be good. I think I'm done with this piece. It's been quite an adventure. It's ready to go back to the customer now. I'm sure he's going to be very happy. I'm very glad I took on this project. It was a big learning experience for me, having to reverse engineer some of the wiring and stuff in here. And I hope that what I've covered can help others that are looking to bring some of these old Marantz 7s back to life. Thanks again for stopping by the channel. I really appreciate it. If you like this content, please feel free to subscribe, and we will catch you on the next one.